In this example, we're going to continue looking at survey data analysis within STATA. So let's start out by looking at a stratified sample. Recall that we're dealing with a population of 500,000 people, and it's broken into 4 different provinces. Within each of these provinces, we're going to sample 250 people. Therefore, our strata in this example are the provinces. So we can analyze our data as a stratified sample in STATA, but we need to first specify our survey weights. These survey weights were very easy to define for a simple random sample because they were the same for everyone in the population. But in this case, we're going to have stratum-specific survey weights. So think about it. If we're sampling 250 people from each province, regardless of the province, what's the probability of a random individual in, say, province 2 being selected? For province 2, it's just going to be 250 divided by the population size of province 2. To come up with our survey weight, we would just invert this fraction, and in that case, our survey weights for people in province 2 would be the population size in province 2 divided by 250, which is the number of people that we're sampling in province 2. Additionally, we can come up with a finite population correction, which in this example is just going to be identical to this fraction right here. So remember that the finite population correction in STATA was just the number of people sampled divided by the population size. That was for a simple random sample. Now we can just index these guys by province, and we can come up with a stratum-specific finite population correction, which is actually identical to the inverse of our survey weight. So open up STATA and let's analyze our stratified sample data. Open up the dataset stratified.dta. The first thing I want to do is generate survey weights. So I would say generate weight stratified, and it's equal to the province size divided by 250. It's the total population size in the province divided by the number of people sampled. And recall that our finite population, FPC stratified, is just equal to 1 over the weight. Essentially, what this finite population correction within stratum does is it takes into account the fact that there is a finite population within province. Once you have your weights and your finite population correction, you can go ahead and survey set your data. So I would say survey set. Again, the identifier in my data set is ID. This all looks exactly the same as simple random sampling. I'm going to say p-weight equals the name of my survey weight. But now I need to say comma, and I need to specify what my strata are. In this case, my strata are province. If I go over here to my variable list, you see I have this variable province that denotes which province an individual lives in. So I say strata province and then FPC, and I put in the name of my finite population correction, which is FPC stratified. Hit enter. STATA tells me, all right, I got your survey weights in there. I see that you're stratifying by province and that your sampling unit is ID, and that you did want to use that finite population correction. So now I can say survey proportion malaria, and using the stratified sample, I get an estimate of malaria prevalence that is 13.1% with confidence interval from 10.7 to 15.5%. So this is really close to what we got with our simple random sample. I'm using the exact same sample size for all of these surveys. So now we have a sample size of 1,000 from a stratified sample, and we get an estimate of 13.1% compared to, if you remember from the simple random sampling, we got an estimate of 12.8%. Again, we can look at the design effect from our survey, which, if you remember, in this case, it's going to be the variance of our stratified sample of the variance for the proportion of malaria using our stratified sample compared to the variance that we would have gotten if we would have used a simple random sample. So I run estat effects, def. And now you see that I get a design effect of 1.28. So this stratified sample isn't quite as efficient as the simple random sample. Now sometimes stratified sampling can actually be more efficient than simple random sampling, but in this example we don't see that pattern, and there's a reason that simple random sampling is more efficient in this example, and we'll jump into that later in some of the questions. But keep that in the back of your mind for right now. All right, the last thing I want to do is I estimate the proportion or the prevalence of malaria using my survey design. I got 13.1. Now take out that survey. Let's not specify the survey design and see what answer we get. When we don't specify the survey design, we see a decreased estimate of malaria prevalence. Now we see that the estimate is 12.6% as compared to 13.1%. So when I don't specify the survey design, my prevalence goes down. Why do you think that that is? To get the answer to that question, go ahead and type in proportion malaria, over province. You could also type in survey proportion malaria over province, and you're actually going to get the exact same answer. But let's not delve into that any further. The reason that those match up exactly when you type survey is because we have a stratified survey. If you had a cluster sample or a different kind of sample, that wouldn't be true. But let's look at our province level estimates of malaria prevalence. We see that the prevalence is generally pretty high in stratum 1, 2, and 3. And then in stratum 4, we have this really low prevalence. It's 0.064. And then if I run table province size, if I want to look at what the population size is by province, I can run table province and then specify exactly what I want it to spit out. I want it to spit out the mean of province size. And province size is actually a constant for everyone, so it's just going to tell me the size of the province for everyone. It's not that important that you understand this command. I just wanted to illustrate for you the fact that in province 1, the population size is 225,000. In province 2, it's 150,000, 3, 100,000. And then in province 4, it's much lower. We only have 25,000 people in province 4, so that's much lower. But think back to our sampling strategy. Remember, we went in and sampled 250 people from every province. So if I don't go in and specify survey weights, essentially what's going to be happening is I've oversampled people in province 4 because provinces 1, 2, and 3 are much larger relative to province 4. But if I just average the outcomes for 250 people over the entire population without thinking about survey weights and without thinking about the population size within each province, I'm going to end up with an underestimate of malaria prevalence. And that's exactly what we saw in this example. So knowing that province 4 generally has a lower malaria prevalence and a lower population size, if we don't specify the survey design, we would expect to underestimate malaria prevalence in the country. So you have to specify the survey design if you have a stratified sample if you want to get an unbiased estimate of the prevalence in this example and in general.